Welcome back to Astronomy 101. We're in Chapter 2, Discovering the Universe for Yourself. And this video is part 2, the reasons for the seasons. So we're going to talk about the astronomical reasons for why we have spring, summer, fall, and winter. Our goals for learning: what causes the seasons and how does the orientation of Earth's axis change with time? So something to think about: true or false. Earth is closer to the sun in summer and farther from the sun in winter. I think most people believe this to be true, assuming that it's the Earth's distance from the sun that affects the seasons. But a hint is, when it is summer in America, it's winter in Australia. And the answer is false. The seasons are opposite in the north and south hemispheres, so the distance from the sun cannot be the reason for the seasons. The real reason that we have seasons involves Earth's axis tilt. Remember that Earth's north axis is always pointed at the star Polaris. There's nothing that attractive about the star Polaris that pulls it to point in that direction. It's just that it happens to be, in these last few centuries, it just happens to be pointing in that direction. As the Earth goes around the sun, remember it's tilted, its axis is tilted at a 23.5-degree angle from perpendicular to the ecliptic plane, and it stays pointing in that direction. So you see, as we go around in the year, that north axis is always pointing in the same direction. The seasons depend on how Earth's axis affects the directness of sunlight. So you see, as we go around, we can start anywhere. Let's start here, December 22nd, and that's going to be plus or minus a day. Sometimes it can be as early as the 20th, sometimes as late as maybe the 23rd. So give or take a few days. This chart here just says the 22nd. But you notice that Earth's axis, north axis, is pointed away from the sun. So if in the northern hemisphere we are pointing away from the sun, we're getting less direct sunlight, and also we spend less time of our day in sunlight. And that becomes more pronounced the higher in latitude you go. But in Porterville, at about 35 degrees latitude, on the first day of winter, which is the most extreme pointing away from the sun, we get something like 10 hours out of a 24-hour day, only 10 hours between sunrise and sunset. And then it's what we consider night for 14 hours. So we get less time in the sun and less direct sunlight, and that leads to winter. That's the winter solstice, the day when our north axis is pointed directly away from the sun. Now keep in mind, in the southern hemisphere, they are pointing most directly towards the sun, so that's actually the beginning of summer for them. Let's continue around in the year. There is roughly March 21st, the first day of spring, and it's known as the spring equinox or the vernal equinox. And this is when we are not pointing towards or away from the sun, but it's the sunlight is just coming perpendicular towards the way our axis is pointing. It's the medium between winter and summer. As we continue around, Earth's axis is still pointing in the same direction, still pointing towards Polaris, but now in the northern hemisphere, we are getting more direct sun rays, and we're spending more time in the sunlight. So in Porterville, at the latitude where we're at, we will have from sunrise to sunset about 14 hours, and then from sunset to sunrise, nighttime, about 10 hours. So more time during the day. Now notice, you imagine the Earth spinning right here. So when a part of the Earth, such as my pointer is at California, when it spins in 24 hours, it gets to right here in the dark, and that means it's nighttime until it keeps spinning and it comes around again to daytime. But look on the North Pole. Right there, as the Earth spins, there is never nighttime. So during the summertime, if you're standing on the North Pole, the sun never goes down. Now, the Earth is spinning, so you'll see the sun go around the sky, but it never sets, never rises in the summertime at the North Pole. So the higher in latitude you are, the more pronounced the effect of the longer days and the shorter nights. I know that if you go to like Scotland, which is in the about, I think, mid 50 degrees latitude, higher in latitude than we're at in California, then during the summertime, the sun will not set till 10 p.m. and it'll rise at about 3 a.m. So they get much more sunlight the higher in latitude you are. And also keep in mind, down south in the southern hemisphere, they're having winter. So notice as the Earth spins, if you're standing right here on the South Pole, you will, during all of winter, you will never get any sunlight. The sun just will not rise for several months. By the way, the equator is the happy medium between these. On the equator, at all times of the year, they always have 12 hours of light and 12 hours of nighttime. Okay, let's progress around. And now we have another equinox. This is the first day of autumn, the autumnal equinox or the fall equinox. And it's just like the spring equinox. We're just facing in a different direction. So we get, that is the day that the sun rises at the same time in the AM that it sets in the PM. So 12 hours of the sun up in the sky and 12 hours of the sun below the horizon for nighttime. And then it progresses along till winter again. The days get shorter in the northern hemisphere and it gets colder. The sun's altitude also changes with seasons. During the summer, remember, we are pointing more towards the sun, and during the winter, farther away from the sun. So this picture shows the sun's position at different times of the year, the same time of day, noontime, but different days throughout the year. And the sun's position is higher in the summertime. Higher altitude means we're getting more direct sunlight. And the sun has a more northerly course, as it always rises from east and then goes down in the west, but its course is more to the north. As you can see here, to the left of the picture is north. Its course is more to the north in the summertime. And as the year progresses, we get to wintertime. Notice the sun is lower in the sky. The sun's position, lower in the sky. Lower altitude means less direct sunlight, and it takes a more southerly course. So in summary, the real reason for seasons, Earth's axis points in the same direction to Polaris all year round, so its orientation relative to the sun changes as Earth orbits the sun. Summer occurs in your hemisphere when sunlight hits it more directly, and winter occurs when the sunlight hits less directly. And so remember, it is summertime for us in the northern hemisphere, and when it is wintertime in the southern hemisphere. Axis tilt is the key to the seasons. If the Earth did not have any tilt to its axis, if it was just straight up and down, meaning its axis is perpendicular to the ecliptic plane that it goes around the sun, there would be no seasons. Now let's go back to the idea that distance might matter. Why doesn't distance matter? Because the Earth, while it does travel in an ellipse, it's not a circle, so it does have a point at which it's a little farther from the sun, that's called aphelion, and a little closer to the sun, that's called perihelion. But it doesn't vary that much. It varies between 152 million kilometers and 147 million kilometers. That's only about a 3% variation. Such a variation would not be enough to cause such drastic changes in seasons. What's much more having an effect is the tilt of the axes, or the axis. How do we mark the progression of the seasons? We define 4 special points. What we know as the first day of summer, we call the summer solstice. Now, solstice comes from the Latin words for sun, so sol is sun, and stis comes from the Latin word for standing. So it's when, as the sun, throughout the months, we go through February, March, April, May, the sun seems to take a higher and higher course every day as it does its daily route through the sky. And then as it progresses slowly to the north, it seems to stand still on about June 21st. And then after that, that first day of summer, it'll start to make its way down, down, down to the south as it takes its daily route across the sky. So that day where it changes direction from north to south, it's standing still, it seems, on that day. That's the first day of summer. That is the summer solstice, roughly about June 21st. On the other side of the year, the winter solstice is the opposite. People since ancient times have noticed that the sun, as we progress from September, October, November, the sun takes a more southerly course. It gets lower and lower in the sky. And then about the end of December, it seems to stand still, meaning it's been taking a southerly course, and now it's changing direction to go back up north. And that day is known as the winter solstice. We mark it as the first day of winter. And actually, it's why we have New Year's Day. Now, New Year's is about a week removed from the winter solstice, but that is the origin of our New Year's Day. It marks the new year when the sun starts to go more and more to the north and bring about eventually summer. Now, the in-between places are the spring equinox, also known as the vernal equinox. That's when we are, as you can see here, it says March 21st, but that's a plus or minus a day or two, when we are not pointing towards or away from the sun. And on the other side of the year in September, that we mark the beginning of fall with the fall equinox, otherwise known as the autumnal equinox. When we get into chapter 3, we're going to look at the ancient origins of calendars. Before people came up with the idea of January, February, March, April, and the months that we know, they had what we consider primitive calendars. And the calendars in many ancient cultures were based on the movements of the sun throughout the sky. It was basically based on these seasons. We can recognize solstices and equinoxes by the sun's path across the sky. Now, if you look at this picture down below, in the summertime, the summer solstice, the sun is at its highest path. So here's a person observing, and you can see to the left is north, to the right is south, and east and west. And if the person watches the sun go rise in the east and go down in the west, it's a more northerly course. It rises and sets at the most extreme north of due east. So it goes up, and about noontime it hits the meridian. Notice it's not at the zenith. There are some places on the earth it's at the zenith, but most places the sun doesn't go directly overhead. But it does cross the meridian, and that's about noontime, and then it goes down and sets. Now, during the winter solstice, the sun is at its lowest path, so it's way down to the south, and so it rises in the east, it hits the meridian, and goes down the west. Notice it's got a shorter distance to travel. It spends less time up in the sky during the winter. And then the equinoxes are the medium in between the solstices. The sun rises precisely due east and sets precisely due west, but it still takes a southerly course if you're in the northern hemisphere. It gets very extreme, as I mentioned before when talking about Scotland, if you go up into the Arctic Circle, most extreme at the North Pole, but at the Arctic Circle, it says here, seasonal changes are more extreme at high latitudes. This is on the Arctic Circle, so at a latitude of 66.5 degrees. And notice what the sun does on the summer solstice. It never goes below the horizon. So here we are, the sun at midnight. If you look due north, it's right there on the horizon, and that's the lowest it gets on the summer solstice at the Arctic Circle. And the Arctic Circle is really defined by, it's the latitude where this occurs. So I said 66.5 degrees. It is not coincidental that that is 90, which is a quarter of a circle, minus the tilt of Earth's axis, 23.5 degrees. And so that's how we define the Arctic and the Antarctic Circle. But so at midnight, the sun is due north, and then it rises and makes its way to the east. So at 6 a.m., it's over here, and it makes its way to the south. So at noon, it is as high as it's going to get in the sky, which is not very high at all, but as high as it's going to get that day. And then it starts to set, like we expect the sun to do at noon. It goes down, down. 6 p.m. due west. And now let's continue back the cycle over to the left here. So it's setting. Now it's getting into the nighttime, what we consider nighttime usually. So 10 p.m., 11 p.m., and it will touch the horizon and then start the new day going up again. So to summarize, what causes the seasons? The tilt of the Earth's axis causes sunlight to hit different parts of the Earth more directly during the summer and less directly during the winter. The summer and winter solstices are when the northern hemisphere gets its most and least direct sunlight, respectively. The spring and fall equinoxes are when both hemispheres get equally direct sunlight. And that is the end of part 2, the reasons for the seasons. Have a great day.